Sir, I have one doubt in that, sir. In the
Okay.
method one of that, sir, actually.
Okay, method one. Okay, I'm going to repeat it again. The method one. Have you written the
Yes,
question?
sir.
You already had have the question, right?
Yes, sir. So
So
just
we
the last part, sir.
okay, last part like what?
Sir, like after adding, then we multiplied it. So like 6 into equation 2, like that.
We just
That
did
part.
a hit and trial method to basically form a equation which is required equation, and the required equation was like uh, in the questions it was given that calculate what was the question?
So the
Wait a minute.
enthalpy of combustion of benzene and that.
Wait a minute. I had the question. Oh, wait a minute, please. Unib, are you? No, 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 no. Wait a minute. Okay, everyone, am I audible? So I'm not getting my question. So sliding it upward slightly. So just see, Krishna, the question was the enthalpy of combustion of benzene at 25 degrees centigrade. That means benzene, the combustion of benzene has an enthalpy change that is given 3267 kilojoule per mole, right?
Yes, sir.
And we need to calculate enthalpy of formation of benzene. Basically, we need to calculate the formation of benzene, the change in enthalpy during the formation of benzene. So we have two methods. The first method was like I already told you, that was product minus reactant. Second method, sorry, the second method was enthalpy of reaction, that is formation of product, the change in enthalpy of formation of product minus change in enthalpy of formation of reactant. And the first method was like there will be information given on which basis, on that base we can easily make a required equation, like the we need to calculate the enthalpy of formation of benzene. So from these three equations, from these three enthalpies, like the combustion of benzene and the formation of water and the formation of CO2, with the help of these three, by heat and trial method, we can easily make the formation of benzene, like I did. Just first write the reaction according to the question. There is combustion of benzene, that means the product will be this. We know that whenever hydrocarbon will burn, or whenever there will be combustion of hydrocarbon, that means the product will be carbon dioxide and plus water, and you can easily balance it. According to the question, there is formation of water, and you can easily make a equation for formation of water, that is H2 plus half O2 will give H2, and formation of CO2 can also be prepared, or you can write the equation C solid plus O2 will give CO2. And with these three equation, we need to calculate, we need to make a new equation in which there will be formation of benzene. That means on the right hand side, or on the product side, on the right hand side, wait, sorry, on the right hand side or product side, there should be only benzene. So you can see the benzene is in left hand side, and we need to uh, move it to the right side. So I just reverse this equation. So the value of combustion of benzene, it was given like 3267 kilojoule per mole. And you know that it is in negative, because this is combustion is exothermic, so it will be negative. So the value will be reversed, the sign will be changed, because we need to calculate the formation of benzene. And now you can see, like if you reverse it, and here it is CO2 in the right hand side, and we don't need CO2. So I just and here it is 6 CO2 on the left hand side, because we just reversed it. And so that's why I multiplied it in by 6, so that CO2 will be cancelled. In the same way, you can go for this and multiply it by 3 and add these three equations, you will get C6H6. Like, I got the one. What I did is reverse the first equation, and then multiplied 6 in equation 2, and multiplied 3 by 3 in equation third. And you can see this was the reversed, after reversing this I got, and by multiplying this I got, and by multiplying by 3, and after adding this we got the required equation, in which on the right hand side it was only C6H6. So it must be so it is confirmed that on the left hand side there will be only carbon and hydrogen, because on the product side we got C6H6. That means product has an atom, that is carbon and hydrogen. That means on the left hand side there will be only carbon and hydrogen, and all other elements, compounds, or whatever it is will be cancelled. So whatever we did in this process, in this step, we just need to do in the same way with the value. So I just did 6 into 2 plus 3 into 3, because in the third equation we multiply it by 3, and from the first equation we just reversed it, so I take it as negative. Is that clear?
Yes, sir.
So it was basically positive, it will be positive, because delta H for combustion is exothermic. So exothermic, in exothermic it is negative, and we just reversed it, so it will be positive. Okay, everyone?
Yes, sir.
Yes, sir.
So you can as easily calculate it. Can I change the slide, Saf? Whoever come. Okay, let me discuss the assignment first. Have you got your assignment? Let me check. I'm sure you have you completed or given any assignments, Ifra? New assignments? Any new assignments? No, sir. Okay, thank you then. So we just whenever you give a new assignment to sir, please let me know, so that I can check it in front of all of you, in front of all of you. Fawaz,
Yes, sir.
do you have any doubt from the last class?
No, no, sir.
Okay, Saif, are you there? Arslan?
Yes, sir.
Okay. If you have any doubt, let me know, please. So going to do another question on the same topic, or it is same as the previous one, like benzene. So try to calculate it peacefully. Calculate the questions in thermodynamics, basically generally usually in thermochemistry, part of thermochemistry, the question will be lengthy, but it is too easy to solve it. Calculate the standard enthalpy of formation, standard enthalpy of formation of methanol, that is CH3OH, in liquid state, that is given in the question, from the following data. From the following data, you can see the question will be too lengthy. Equation A, that is CH3OH in liquid state. Wait a minute, please. It's hanging, so I'll just 3 by 2 O2 gaseous state will give CO2 plus 2H2O liquid state, and here it will be gaseous state. Here it was given that delta RH equals to minus 72626 kilojoule per mole. Wait a minute. C graphite plus O2 gaseous state will give CO2 gaseous state, and here it will be delta CH is equal to minus 393. That is, enthalpy of combustion is given as minus 393 kilojoule per mole. C is for combustion, and the third equation, which is H2 in gaseous state react with half O2 in gaseous state, will give H2O in liquid state. And here the formation of H2O, that is water, is given as minus 286 kilojoule per mole. Kilojoule per mole. You can easily solve it in the same way as we did in the previous question. Okay. Can you do it, Ifra, Fawaz, Krishna, Arsalan, Saif?
Yes, sir. We'll try.
Yes, sir.
It will be solved in the same way as the previous one. You can apply both method, or you can apply the first one, whatever. I will suggest you to do in both way. Any answer? Everything was given. Ifra. Ifra. Okay, waiting for your answer. For all of your answer. Fawaz, are you solving it? Krishna.
Yes, sir.
Yes, sir.
Okay. The answer is 239. Krishna, you are wrong. Just read the question. Calculate the enthalpy, standard enthalpy of formation of CH3OH. We need to form CH3OH. So you can see CH3OH, that is methanol, and in these three equation, one of these three equations, CH3OH is in the left hand side. So we need to reverse this equation, and according to the requirement we will multiply as well as, then after that we will add or subtract from each other. Now you know what we need to do is, first we are going to add second equation plus third equation, and we need to multiply it by 2, and then reversing the first equation, so I just put it -1. Okay, Very good for us. Now see what I'm going to do. Whatever I just write here, wrote here, they see second equation. What was the second equation? The second equation is C, that is graphite. I'm writing it GRFT, graphite, and then O2, adding O2 and multiplying before writing second equation, multiplying it by 2. No, sorry, it is the second equation. I just wrote the second equation, so I was right. C graphite, and then we are going to add O2 in gaseous state, then multiplying the third equation, that it will be 3H2, and then it will be 3 by 2 O2. And then reversing the first equation, after reversing the first equation, we will get CO2 plus 2H2O. That will be, it will be in left hand side reactant. And what is on the right hand side? On the right hand side, it will be CH3OH plus 3 by 2 O2. And in the second equation, we will get CO2, and in the third equation, it will be multiplied by, it was multiplied by 2. The third equation was multiplied by 2 now. Okay, let me correct it. If it is multiplied by 2, then we will get basically 2 here and 2 here. Are you getting my point?
Yes, sir.
Saf?
So please repeat it again.
Okay, wait a minute. Wait, no problem at all. I'm going to do it step by step. First, whatever I'm going to do, I'm going to write it. No problem. Here is 3 equations. Saf, answer me the question, whatever I'm going to ask you. What we need to calculate is enthalpy of formation of CH3OH. If we need to form, or if we need to make CH3COH, if we need to prepare CH3COH, that means CH3OH should be on right hand side, on product side, yes or no?
Yes.
So we just need to reverse the one. Reverse equation 1. Now see, this is graphite. Second equation, with second equation, what I'm going to do is if you just reverse this equation, first equation, CO2 will be in the left hand side, right?
Yes, sir.
And this CO2 will be on the right hand side, so it can be cancelled. You just don't need to reverse this and neither multiply this, because in this equation CO2 is in the left hand side because we just reversed it, and in this equation it is on right hand side, so it will be cancelled. We don't need CO2. So I just add equation 2, and with equation 3 I am going to multiply it by 2. So whatever I am going to do, I am just writing it, multiply it by 2, multiply it by 2, and you just need to do this and reverse this. So after doing all this, I am going to write it stepwise. First equation will become, first equation will become like CO2, because we are going to reverse it, and then 2H2O, that will be in liquid, and after that here it will be CH3OH, and then it will be 3 by 2 O2. You can easily see. And B will be written as it is, so it will be C plus O2 will give CO2. And in the third equation, I just wrote multiply it by 2. So after multiplying it by 2, we will get 2H2 plus in this we multiply 2 in half, that will be O2, right? Safe.
Yes, sir.
So after and you we need to multiply it here too, so it will be as 2H2O, right? So whatever we did, we are going to add all these three. So after adding all these three, we get like CO2 plus 2H2O. On the left hand, it will be in left hand side, O2 plus 2H2O, 2H2 plus it will be O2. And then on the right hand side, it will be CH3OH. It will be 3 by 2 O2, 3 by 2 O2, and it will be CO2 and also 2H2O. Now you will see Whatever is going to cancel, just cancel it. CO2 will be cancelled by CO2. Where is CO2? Here it is CO2. Is it good?
Yes.
Now go for H2O. H2O will be cancelled by H2O, right?
Yes.
Now see, carbon, hydrogen. We need to make CH3OH. Hydrogen won't be cancelled because there is no hydrogen on the right hand side alone.
Yes.
Now concentrate on this. C plus O2 plus O2 will be O2 plus O2 will be C plus, I'm going to write 2H2, and here O2 plus O2 will be 2O2, right? And here
Yes.
it will be only left CH3OH plus 3 by 2O2. And you can see O2 on the left hand side as well as right hand side. So moving uh, only in one side, here it is 3 by 2, that is 1.5, and here it is 2. So I am going to move it to the left hand side. So it will be 2H2, and you know that whenever it will change side, its sign will be changed. Like in this, it is in positive, so on the left hand side it will be in negative, and when we will calculate it, we will get 1 by 2 O2. We will get 1 by 2 O2. We will get or not, Saf?
Yes, sir.
So it will be 1 by 2 O2, and here it will be CH3OH. And just check it is balanced or not. It will be balanced. There is only one carbon on the left hand side. Right hand side, there is only one carbon hydrogen. There is four hydrogen on the left hand side. On the right hand side, there will be four hydrogen, and oxygen here it is one, and on the right hand side oxygen is one. Now see what we did, we are going to do in mathematics. Delta H equals to, first you can see that the second equation we just added graphite, the graphite one, graphite, C plus O2 will give CO2. So I'm going to write it as it is minus 393, plus we just multiplied by 2 in the third equation, which has a value, what it was, minus 286, minus 286. And the last one, in which we just reversed, so it won't be positive but it will be negative, and the value is minus 726. So after reversing, the value will be in negative. So you can see after calculating it, you will get minus 239 kilojoule per mole. Krishna,
Yes, sir.
got it? What you what you had done?
Sir, can you solve it in this the second method also?
Yes, I will solve it. First write let write it. Everyone, whoever didn't solve this, please write it. Saif, are you done with this?
Yes, sir.
Okay. Can I change the slide?
No, just scroll down. I want to see the that enthalpy part.
This much? Or I can scroll down more.
More, sir.
Is it good?
Yes, sir.
Sorry. Very good, Arsalan. If you're done, Seth, let me know. Fawaz, you already did it. We will solve it by second method too. Krishna, are you done with this?
Yes, sir.
Okay.
I got from the second method also, sir. I had done some small errors, so I didn't get it.
Okay, okay. I will explain it just after this.
So finish it.
Finished. So basically, in the question, it was given that combustion of ethanol was given. That is methanol. Sorry. Calculate the standard enthalpy of formation of ethanol. And in the question, it was given combustion. The first equation is combustion of methanol, that is CH3OH. So we are going to write this equation as it was given. CH3OH plus 3 by 2O2 will give CO2 and then 2H2O, right? And
Yes,
we
sir.
can, if you remember, then delta RH, if you remember, and delta RH is equal to sigma delta FH of product minus delta, wait, I just, okay, it's okay, good, delta FH of reactant, right? And the delta RH is given as -726. Everyone, formation of ethanol or reaction of the ethanol, it was given as basically -726. Okay, so I am going to write it. And what is about the product? CO2. CO2 is given. CO2 is given or not?
Yes,
-393.
sir.
It is given CO2 -393 plus, what about H2O? H2O is also given, plus 2 into -286 and minus the reactant. Come to the reactant side, we need to calculate this value. So I'm going to take it as X plus, what is the value of O2? I told you that in previous class that it is 0. Now we just need to calculate X. It is -726 and it will be -393 and it will be -26 is 12 and then 2 8 16, then it will be 17, 2 2 is 4 1 5 and it will be -X. Now just do this here and do this here. X will be equal to, after solving this, 2 2 3 5 7 9 16 and 5 7 8, that will be 9. And after removing it here, moving it to the right hand side, 7 to 6, that will be equal to -239 kilojoule per mole, right, Ifra? Saif, Arsalan, everyone.
Yes, sir.
Yes,
Yes,
sir.
sir.
So
Sir, C3OH is X here.
yes, delta R is the reaction enthalpy or the combustion enthalpy. So you know that the combustion, the enthalpy change during uh, combustion will be equal to the reaction enthalpy. So we just put as this, and for only CH3OH, it is, I'm taking it let it be X. In the same way as we did for benzene, if you are remembered.
Done, sir.
Okay, very good. Everyone done, Saif?
सर 1 मिनट रुक जाओ.
Okay. Saif, what about you?
I completed.
Okay. First, let me know when you are done. Arsalan? Sorry.
Done, sir.
Done? Sure.
Yes.
Okay. Enthalpy of combustion of carbon is minus 393.5 kilojoule per mole. Calculate heat released upon formation of 35.2 gram of CO2 from carbon and dioxygen gas. Very easy this question is. And let me know if you are done. Ifra, Krishna, Krishna, are you able to do anything about this?
No, sir. Can
Okay,
you explain?
just say enthalpy of combustion, everyone. Enthalpy of combustion of carbon. It is talking about only carbon. So carbon in solid plus combustion. We must react with O2 to give, it will give CO2, carbon dioxide. And it is given that enthalpy of combustion, it is given that enthalpy of combustion of CO2, or we can say formation of CO2, formation of CO2, that will be equal to delta H is equal to basically 393.5 kilojoule per mole. This enthalpy is for 1 mole or not? For 1 mole, right?
Yes, sir.
Yes, sir.
Now you know that basically CO2 has molar mass that is 44 gram, and 44 gram represents 1 mole. So 1 gram for 44 gram represents 1 mole, and for 1 mole CO2 it is given that the enthalpy is basically 393.5 kilojoule per mole. Saif, are you getting it?
Yes, sir.
Now see, why I am doing it in gram, because the question is asked in gram. So I'm going to calculate for 1 gram. For 1 gram, it will be, the enthalpy will be minus 393.5, because for you know that 44 gram corresponding to 1 mole. So for 44 gram it is minus 393.5 kilojoule per mole. So in the same way, for 1 gram it will be minus 393.5 divided by 44. And in the same way we need to calculate for 35.2 gram, that will be equal to minus 393.5 divided by 44 into 35.5, 35.2, and this will be your answer in kilojoule. Is that clear?
Yes, sir.
Okay, just write it. If you are done, let me know, please. Very good, Ifra. Everyone wrote it.
Yes, sir. Done.
Okay. We have another formula. Just remember it. For bond energy, if bond energy of reactants and products are given in the problem, then delta RH is equal to, here it will be reactant first, sigma bond energy of reactant minus sigma bond energy of product. Write it. Done, everyone?
Yes, sir.
So basically, whenever there will be bond enthalpy, or it will be like bond dissociation enthalpy, bond dissociation enthalpy. That means we need to break the bond. If we have diatomic molecules, diatomic molecules, that means two atom diatomic, that means two atom. So whatever energy or enthalpy will be required to break this bond to make it atom, this enthalpy is known as bond enthalpy or bond dissociation enthalpy. Is that clear?
Yes, sir.
Just see, for polyatomic it is for diatomic. For polyatomic, the bond enthalpy is basically mean bond enthalpy. What we say, mean bond enthalpy, average bond enthalpy. Just like if we have CH4 and bond enthalpy is given, because we need to break four other bonds, only not CH. We need to calculate crack this bond and this bond and this bond. So whatever bond is given, bond enthalpy is given, we need to divide it by 4, because for one bond the for the bond enthalpy of one bond, it will be delta H by 4. In the same way, if we are going for NH3, you know that there is 3 bond. So if there is bond enthalpy given, it is polyatomic, so it the bond enthalpy will be delta H by 3. Are you getting my point?
Yes, sir.
Yes, sir.
So just write it.
Done, sir.
Very good, everyone done. Okay.
Sir, can you explain again for bond enthalpy for diatomic molecules?
Diatomic molecules, because only there will be diatomic, that means 2 atoms present, there will be only one bond now.
Yes, sir.
So if we give enthalpy, whatever is the enthalpy, it will be for this bond. But whenever there will be it will talk about polyatomic bond enthalpy of polyatomic, it will be according to the compound, there will be more than 2 bond, so more than one bond. So whatever you can say, the number of bond will be divided by the enthalpy will be divided by number of bond. You can see if there is 3 bond, the bond enthalpy will be divided by 3, because the bond enthalpy in polyatomic is given by mean bond enthalpy. Is that clear, Krishna?
Yes, sir.
Okay, can I change the slide?
Yes, sir.
Now come to the new topic, which is entropy. It is denoted by S. We already know that entropy is a state function. What it is a state function. So I'm going to define it. Basically, entropy is degree of randomness. Entropy is degree of randomness, where there is more disorderness or randomness of particle, of molecules, gas, that that will have more entropy. I'm going to explain it again. The thermodynamic quantity, the thermodynamic quantity which measure the randomness or disorderness of particle of system, you can say, of the system is called entropy. Now we have three container in which solid is present, and the another is in which liquid is present, and the third one which has gases. Tell me the particles of which container will have more disorderness or randomness.
So gases.
Any other answer? Anyone else?
Sir, it's gas solution.
Gas, because the gaseous particles are far from each other. Very good, Ifra. Gaseous particles will be far from each other. There will be less force of attraction, so it will be, there will be more randomness. And what when we talk about liquid, the particles are very closer than gaseous gas particles, and here it will be very less disorderness. And what about solid? Solid is highly compressed, so the randomness here is very low. So whenever we need to do this, entropy of gas is greater than entropy of liquid is greater than entropy of solid. As we cannot determine internal energy, basically absolute internal energy and absolute enthalpy, in the same way we cannot determine absolute entropy, so we always calculate change in entropy. Are you done with this slide, Saf, Krishna?
Yes, sir.
Yes, sir.
Randomness is something when particles goes from here to there, that is randomness. Okay, Fawaz?
Okay, okay, sir. Okay.
Movement, there will be no very less force of attraction, that will not be compressed, so it will move freely. So here a point will come, right with me. Absolute value of entropy of the system cannot be determined or calculated, but only change in entropy can be measured. So for chemical reaction, we will have a formula delta S system, that will be equal to sigma delta S product in product minus delta S reactant. Write it and let me know.
Done, sir.
Done, everyone?
Yes, sir.
Yeah, Fawaz, Arslan, Ifra. Okay, very good.
Done, sir.
Very good. Right, factors affecting the entropy. Factors affecting the entropy or randomness, you can say. Factors affecting entropy or randomness. First, physical state. Physical state, as you know that I just explained, and you already know that entropy of gas is greater than entropy of liquid is greater than entropy of solid. B, that depends upon temperature. When we increase temperature, the randomness will increase. Will it increase or not?
Yes, sir.
Temperature increases, randomness of particle, the velocity of particle will increase. And if the velocity of particle will increase, that means randomness will increase. That means delta S, you can see S will increase, that is entropy will increase. And after that, if you are going to find delta S, if delta entropy increases, that means delta S, the final value will be greater than initial. That means delta S will be positive or not. Are you getting my point?
Yes, sir.
Okay, write it and let me know. I'm going to explain the second one. Pressure. What about pressure? If we increase the pressure, tell me, if we increase the pressure, the volume will be decreased, and if the volume will be decreased, there will be very less space to for randomness. Is that clear, everyone?
Yes, sir.
So randomness will be decreased because volume is decreased. Randomness will decrease. That that means entropy will decrease. So delta S will have negative value. Is that clear?
Done, sir.
Done, everyone. Saif,
Sir, 1 minute.
okay. Saif, am I audible to you? You are not speaking.
Yes, sir.
Okay,
Also 1
sorry.
minute.
Wait a minute. Actually, you were not audible. That's why I was asking.
Done, sir.
Very good. Fawaz, what about you? Fawaz, am I audible to you?
Yes, done, sir. Yes.
Okay, I'm going to give you a simple question, which is very easy. If I'm going to give you H2 gaseous state and H2 gaseous state, here the pressure is 2 atm and here the pressure is 5 atm. Tell me the sign of delta S, positive or negative?
So negative.
Negative.
Negative. The word delta S value will be negative. Pressure increases, that means basically the entropy here will be decreased by here and the value will be negative. Very good. Everyone good with this? So I'm going to write another example. Wait a minute. Condition of gas. Condition of gas. Whenever number of moles increases, just let me know. If there will be more number of moles, if there will be more gaseous particles, the the randomness will be more. That means delta S will be positive. Yes or no, Krishna?
Yes, sir.
Now see, temperature increases, delta S will be positive. because
Yes.
the particle will move faster, and if volume will increase, that means volume increase, there will be more space for randomness, that means entropy increases, then delta S will be positive. If pressure will increase, that means volume will decrease, and if volume will decrease, delta S will be negative. Is this clear for everyone? If we increase number of moles, delta S will increase. If we decrease number of moles, delta S will decrease. Okay.
Okay, sir.
Here is one other important thing to learn. Whenever we add, basically we are going to mixture formation, we are going for mixture formation. And what is mixture formation? When we add gas into gas, when we add liquid into liquid, when we add gas into liquid, gas plus liquid, when we add solid plus solid, the delta S will increase because particles will increase. Always remember. Now I'm going to give you a question. First write it, and if you have any doubt regarding entropy, please ask me.
Done.
Saif, are you done with this? Ifra, Arslan, Krishna?
Yes, sir.
Okay, I'm going to change the slide. So write the sign of delta S of following a CaCO3 solid will be converted into CaCO, sorry, CaO plus CO2. This is gas, this is solid. B is N2 gaseous state plus 3H2 gaseous state will give 2NH3. Wait a minute, it's too heavy. Two NH3 gaseous state. C is PCl5 gaseous state will give PCl 3 gaseous state plus Cl2 gaseous state. D is carbon solid plus half O2 gaseous state will give CO gaseous state. E is NaCl first in aqueous solution is converted into NaCl solid. Any answer? Krishna, Saif, Fawaz, Ifra. You should solve from A. Ifra directly on B. Sorry, E. Krishna, any answer from you?
Yes, sir. I'm sending.
Okay. Saif,
I'm writing the questions in 1 minute.
okay, okay. Take your time. Fawaz, C is correct one, D is the wrong one. A is wrong. B is also wrong. Take your time and solve it. Krishna, think about D. Except D, all the four of your answer is bad. If no answer from you, okay. This is not mixture, Fawaz. This is not mixture. This is reaction. This is reactant, and after reacting, it is forming product.
Okay, okay.
Okay, so Arsalan, your answer? No answer? Saif? Any answer from you, Saif?
1 minute, sir.
Okay. Arsalan, where are you? Please do reply in chat box. Okay, I'm going to explain it. CaCO3, CaO, and CO2. You you will see that in reactant it is in solid state, and here it is in solid state and gaseous state. So it will be positive because initially it is in solid state, and solid state has very less randomness, but finally it is solid state as well as gaseous state, because of in gaseous state finally its entropy increases, so delta is greater than 0, that means positive. Okay, now see, here everyone is in gaseous state, that means reactant as well as product. But in reactant you will see that there are 4 moles. Here it is 4 moles, 3 moles of hydrogen and 1 moles of nitrogen. And in product you are you can see that it is only 2 moles. It is only 2 moles. So number of moles decreases entropy decreases, and if entropy decreases, that means delta S will be negative or not, because delta Ng has a value -2. You can calculate it by this, or you can see the number of moles is decreased or not. Fawaz, Saif.
Yes, sir.
Now see, all are in gaseous state, but in product side you can see two moles, one mole of Cl2 as well as one mole of Pcl3 and one mole of Pcl5. So here you can see delta Ng equals to 1 plus 1, that will be 2 minus 1 is equal to 1, that is positive. Number of moles increases, so delta is greater than 0. Number of moles increases, entropy also increases. Now come to this. This is in solid state. Only this half mole is in gaseous state, and here it is 1 mole in gaseous state. So you can see that number of moles, whenever we take number of moles, it should be in gaseous state, gaseous product or gaseous reactant. So when you are going to calculate it, it will be 1 minus half. That will be positive number. Half is a positive number. So delta S here will be greater than 0, because number of moles sorry, number of moles of gaseous products increased by half. And now you can see here it is aqueous solution. That means there will be some disorderness as compared to solid. Solid has very less disorderness as compared to liquid, and then aqueous. So delta S will be negative. Seth, is there any doubt?
So D1 is positive, right?
D is positive. Yes. D is positive.
Sir, can you repeat why E is negative?
Why E is negative? Let me know. Solid liquid gas, which has more randomness. Gas, liquid, solid,
Yes.
right? Now, if this has a randomness greater, that means more entropy, positive, positive, positive. Now you see, solid, in between solid and liquid, there will be aqueous solution. Have you heard of it? Aqueous solution.
Yes, sir.
Water present. That means it is talking about molten state. You can say that, or molten state has a little bit more disorderness than solid state. Is it?
Yes.
Yes or no? So if
Yes.
we are going from molten state or aqueous state to solid state, the entropy will decrease, because in solid state there will be very less disorderness. So delta S will be negative.
So, but it is going back to aqua state also, right? So it should be equal to 0.
Going back to,
Aqua state also.
so if you are going through two reactions like aqueous solid then solid aqueous, then it will be 0. Okay, if I will put it like H2 in gaseous state and here H2 in gaseous state at same temperature, same pressure, the delta S will be 0. Okay.
Yes, sir.
Done.
Yes, sir.
Okay. Saif, are you done?
Yes,
Fawaz,
sir.
Arsalan, Ifra.
Yes, sir.
Yes, sir.
After it is F, that is rusting of iron. Let me know it is positive or negative. After F, it is Z, right? Precipitation. You know that what is precipitation? Crystallization. Polymerization. First, what is this negative 100%? 100% wrong answer. H. Oh, you are talking about H. I thought it was F.
Yes.
Why it is so? Can you explain it? Done, everyone? Oh, very good. F. F is the wrong answer. Ifra. Saif, are you solving it?
Yes, sir.
What about I, Krishna? You didn't solve this,
Sir, I don't know what's
right?
polymerization, sir. Can you explain?
Okay, I will explain it. Don't worry. Actually, this F is wrong. You wrote it negative. I'm waiting for your answer, Saif. Very good, Ushma. What about F? Seth, any from these five questions? Have you got your answer? Seth, am I audible?
Yes, sir, you are audible.
Hello, can you hear me, sir?
Yes, yes.
Yes, you're audible to me.
Only H and this J is correct. I, you haven't solved it. Okay, see. Rusting of iron is what? There is solid iron in which gas goes and react with it. Mixture of gas and liquid. I just wrote it delta S greater than 0 in the mixture. Just watch your notes carefully. You will get your answer. Is it okay? I'm going to show you. Okay. So add this also. Gas plus solid. Why you wrote negative? This add this to your notes. Gas plus solid. That's why it is basically delta is greater than 0. What about precipitate? Precipitate, that means it will be formed in solid state. That's why the entropy decreases because randomness decreases and delta S will be negative. Is that clear, everyone? In the reaction, precipitate comes out and we can easily filter it out. So delta S decreases because it comes in solid form, and in solid form randomness decreases and entropy decreases. What about crystallization? Because it comes in solid form, so it's also delta S less than 0. What about polymerization? Polymerization, basically, see, what is polymerization? When very large number of molecules combine together to form a single compound, that is known as polymerization. Poly means many and mer means many. Poly means many, mer means basically side, combine with each other to form a single. Like if you are going for, polythene, Krishna,
Yes, sir.
polythene is prepared from ethene. This is monomer, only one molecule of ethene, and this is polymer. What happens here is, do you know the formula of ethene? CH2 double bond CH2, right?
Yes, sir.
When n number of ethene combine, 1 mole of, or you can see like this, is formed. This n will be here, and it will be only one. Here it is n number, like if you are going for 2, then it will be come here 2, and it will be only 1 mole, and here it will be n mole. Got it, Krishna?
Yes, sir.
If I am writing it like, just see Cl2, and if I am writing it 2Cl, how many moles are here?
2 moles.
And how many moles are here? 1 mole. So delta S will be negative, right? For
Yes, sir.
this. So in the same way, you can see, whenever there are large number of moles combined together to form a single molecule, that will be very large, that will be only a single molecule, that is called polymer. Okay, everyone? Seth, Fawaz, if you have any doubt,
Yes, sir.
ask me.
Okay, no, sir. No,
Okay, okay. Can I change the slide?
So, sir, for polymerization, delta S is negative.
Yes, because in initially the number of moles will be greater, and finally we got only one unit.
Yes.
So the number of moles is decreasing, na? That's why. And here you can easily got it correctly. Can I change the slide?
Yes, sir.
Yes,
Okay.
sir.
So write a topic: mathematical definition mathematical definitions of entropy. What is mathematical definition of entropy? It is defined as ratio of it is defined as a ratio of heat exchange. There will be formula from this definition. Heat exchange in reversible manner in reversible manner to the absolute temperature, to the absolute temperature. So we will have a formula of entropy, basically change in entropy. That formula says delta S system will be equal to Q reversible divided by temperature. Please write it with me, or we can also write delta S surrounding is equal to minus Q system upon T, because system will give heat to the surrounding, so it will be minus Q system.
Done, sir.
Done, everyone.
Done, sir.
Very good. Wait a minute. So write a point conclusion, basically. Very good. Conclusion it is. Write with me. The temperature present in denominator represent the system in randomness. Second point we can write a system at higher temperature has more randomness than one at lower temperature. Than one at lower temperature. Third point we can write heat added to a system at lower temperature that means delta S will be decreases or delta S equals to 0 because heat is lowering, causes greater randomness than when same quantity of heat is added to it at its higher temperature. So basically higher temperature, at higher temperature if it will be added, then entropy will be decreased because we have a formula delta S is equal to Q reversible upon temperature. If we increase the temperature for same heat, this value will decrease now. If rough was
Yes.
Krishna Saf.
Yes, sir.
Okay, just write it and let me know if you are done. In general, whenever we talk about temperature, if we increase temperature without talking about enthalpy, without giving enthalpy, the entropy increases. But whenever the enthalpy will be given, we will put the value of enthalpy as well as temperature. You will see if temperature rises, entropy will decrease. Right?
Yes, sir.
Okay. Can I
Yes,
change the
sir.
slide?
Yes, sir.
Yes.
So you know that delta S system is equal to basically Q reversible upon T, right? We will have a general formula of S, delta S, or for delta S you can write. Now, you know that ds is equal to dq by T. Can I write it? In place of delta, I can use D and it will be dq. Can I write it as D u minus W upon T? You already know that delta U is equal to Q plus W. Wait a minute. Just see, delta U is equal to Q plus W. So Q is equal to W minus delta U. Okay.
Yes, sir.
So basically I can write this and ds will be equal to du by dt minus, sorry, this will be T. Basically the derivation is not so important, minus dw by T. We can write like this. And we already know that for du, it will be du will be ncv dt upon T minus, it will be minus, this will be minus nRT dv, nRT dv, and negative will be positive and divided by v. Wait a minute, dw has the work done, that will be equal to minus pdv, and that is equal to, for p it will be equal to nRT delta ngRT. So we can easily write this and divided it by T, and it will be cancelled for T and T, and the final formula that will come. NCRT, I don't think NCRT has this formula. NCV dt upon t plus nr. Do you know integration, everyone? So
Yes, sir.
we
Yes, sir.
need to do this formula only. It is very easy.
So can you explain how you cancel T and T in that?
Basically, T was already there, right? And dw has a formula minus p external into dv, and p external pv is equal to nrt, we already know that. So p is equal to directly I
Yes, sir.
can write nrt upon v, and t was there, and dv will be here, so t will be cancelled. Okay,
Yes, sir.
just write it. Everyone done with this? Oh, okay, we did.
Yes, sir.
Minutes.
Yes, yes, I will wait for yourself and for us. So we will have some formula on this base. After this, we will have Gibbs free energy and spontaneity, and then what enthalpy of solution, hydrogen, and the chapter will be completed. Done. Safe.
Yes, sir, done.
Okay. So you can see that we have a formula that is ds is equal to ncv dt upon t plus nr dv upon v. So we can also modify it as delta s is equal to basically ncv. We can take it after differentiation integration ln t2 upon t1 and plus nr ln v2 upon v1. After integration, we will get this, and again delta s in terms of log. This is ln, that is base for e. It will be 2.303 ncv log of t2 upon t1, and here it will be plus 2.303 nr log of v2 upon v1. In the same way, you know that from Boyle's law we have a formula p1 v1 is equal to p2 v2. That means p1 upon p2 is equal to v2 upon v1. So I can easily replace it. Delta S is equal to 2.303 NCV log of T2 upon T1 and plus 2.303 NR log of, in place of V2 by V1, I'm going to write it P1 by P2. Will that be okay?
Yes, sir.
Yes, sir.
Thank you so much. Just write it and do complete the assignments that I have given to Niskar sir. I will discuss it on Tuesday. Let me know if you are done with this.
Done, sir.
Fawaz done.
Done, sir.
Saif,
1 minute, sir.
Arslan, Fawaz, Arslan, one. If you are done, let me know. There is a homework for this. Basically, for this formula, find the value of find delta S for first case isothermal. Take it as isothermal. What will be the new formula? Isochoric, as well as you need to calculate, and then isobaric as well as isobaric. Okay, Krishna.
Okay, sir.
Right, and have a good night. See you for next class. Saif, if do you have any doubts, just write it and let me know. If you have any problem in the question or concept.
So what you heard now is homework.
Find delta S, the formula, just I wrote this formula or this and this. For isothermal, in isothermal, temperature will be equal, right? Temperature will be equal. That means this will be cancelled, and log n or ln1 has a value. You can put it here too. If you will put it, temperature will be equal, because in isothermal process temperature is constant and this value will be cancelled, and log 1 has a value 0. Then this whole quantity will be vanished, and only for isothermal process we use this formula only. In the same way, we need to calculate for isochoric as well as isobaric. हो गया?
Yes,
Yes,
yes.
sir.
Okay, then see you in the next class, both of you.
Thank you, sir.